Are we recording? Yes, we are. Okay, so we are on lesson 3, practical problem solving and programming. We did this lesson on the Sunday, and we had 4 students who went here: Tom, Yusuf, Reem, and Daniel. Started off the lesson with a little starter activity. So we've got there, draw a flowchart for an algorithm which calculates how much money a student will need per week to buy a meal and 2 drinks each weekday. The user should be prompted to enter how much a meal costs and how much a drink costs, and then calculate and display the total required. So what I'd like you to do is pause the video and attempt the flowchart. Okay, so once you pause the video and attempt the flowchart, we'll go through the solution. So here is the solution. So we start the flowchart off firstly by prompting for the meal cost, which is an input. Then we input the meal cost, prompt for the drinks cost, input for the drinks cost, okay, and then we calculate using the process box. Where the weekly total, which is the variable, equals meal plus 2, and then times that by drinks, and then times it all by 5. Okay, and then we've got display weekly total. Now, obviously there is a mistake on this flowchart. The mistake is here. This process box. This process box shouldn't be a process box. It should be an input or an output display. Okay, so you're displaying to the output. Okay, so the outcomes of this lesson is to strengthen our knowledge of flowcharts. Our objectives were to use standard flowchart symbols, use standard arithmetic operators, and use total and counting. A copy of this PowerPoint is on Edmodo, along with the worksheets and the answers for the worksheets, all located on Edmodo under lesson 3. So let's have a look at algorithms. So just a reminder that algorithm is a series of steps to solve a given problem, okay? And a flowchart is a common tool used to help plan and write down these steps. So a flowchart is one of the ways we could answer our questions in our past exam paper. Another way to answer some of the questions would be pseudocode or a Python program. But in this lesson we're finishing up and strengthening our knowledge on flowcharts. Next lesson, lesson 4, is where we look at pseudocode and we look at how to test and the type of data that goes into computer systems. And then after that we'll delve further into pseudocode. So, flowcharts. So we've got a flowchart there. I'm going to put my screen over there. Okay, so we've got a flowchart there. An algorithm is a series, a set of steps to solve a given problem. Okay, so where we've got a flowchart there, okay, which asks the user to input their chosen ID. The user would input the ID, and then there is a decision. The question is asked: is this ID already in use? If it is already on the table of IDs, they would have to choose another ID. And if it doesn't exist, then you would store that ID. Now, in terms of the loop that is there, we discussed as a class that it was a conditional statement, and you would use an if loop to create that loop. Essentially, this flowchart represents the idea that you're inputting a username, and if it already exists, then it keeps asking you for a new username. And once you type in a unique username, it stores it. One of the things that we spoke about during the lesson is the input ID, or the chosen ID, the ID variable. How is it stored? We discussed that it is stored as a list or set of arrays, okay? Because you need a number of usernames. You would have a list of usernames to look through. So we can actually break that loop down into a set of subsystems where you're actually scrolling through the list in the variable. Okay. The next slide which was arithmetic operators. This is an additional reading section. We talked about the basic operators that were used in Python. We've got the exponent, the integer division, and the remainder. Just talking through the integer division, there's an example calculation which I've put in there. So 17 divided by 3, which would be 5. There is a remainder, but it's 5. 5 is the number of times that 3 would go into 17. And when you want to work out the remainder of that value, it's the mod. Okay, so 17 mod 3, which will divide 17 by 3, which would give us 5, but there is a remainder of 2. Yeah. So another additional reading section. So we've got another section where we're looking at counting and totaling. So we need to look at this flowchart. You will come across this flowchart in your exam. You may have to create and implement this algorithm or this section of the algorithm into your answer. So when you're answering a question where you have to create a flowchart, you may be required to put in a count. This is an example of a count flowchart or count algorithm. So what we've got there, we've got the variables total and count. And at the first instance in the process box, the count, the number 1 is added to the variable count, and then the total is added to count, and then we would ask the question, is count equal to 1,000? If it's not, it will keep counting until the count variable has reached 1,000. And then we would output the total. Okay, so the statement there, the statement is count equals count plus 1, which means add 1 to the variable called count. Okay. Yeah, it looks like my face there. There we go. Okay, so once we've done that, we looked at 3 basic structures of programming: sequence, selection, and iteration. And what we're going to do is we're going to have a look at tasks 1 and task 2 on the worksheet, which is on Edmodo. So we'll go through the tasks, and then what I'll do is, if you can pause the video, attempt the tasks, and then unpause it and come back to me. Okay, so going through the worksheet. Okay, so we've got the first task there. It says Jasmine plays a game on a computer screen. A moving balloon appears on the screen, and she has to pop the balloon by clicking on it with the mouse. When the balloon is popped, another one appears automatically. So the aim of the game is to pop as many balloons as possible in 1 minute, and the flowchart for the game is shown below. Okay, so let's go through the answers for that. Okay, so here are the answers. Shift my face to the side. Okay, so we start off with the question, the statement there. So it says complete the statement A. Now, statement A should have the variable, and you must initially have the variable set to 0. Okay, and that is in a process box. Okay, so once you set the variable to 0, because you're starting from scratch, you display the balloon, and then complete the statement in statement B. We've got B is here. So time has to be less than 60 for it to carry on. So if the time hasn't run out, the loop will continue. Okay, and in the loop where it says complete statement C, so where we've got the balloon is touched, once it's touched, we need to add 1 to the variable balloon score, and then that value is stored or stored into the original variable there. Okay, so what we do, we take the initial variable, so if that said 1, we'd say 1 plus 1 is 2, and then we would save it into the variable again, so record over the data. Okay, once that is done, we would display a new balloon, and then we'll come down to the decision, and we'll see if the time has gone over 60. Once it has gone over 60, we will be able to output the score. If it hasn't, we'd have to follow the path up in between the decision and the display balloon process. Now, the reason why it comes here and joins up here and not into the process box is essentially, if you was to have this loop go into the process box, you would display a balloon and then display another balloon, essentially. Yeah. So you would keep displaying a balloon. You'd end up having two balloons being displayed, because you'd have a display balloon there, and then you would display another one. So you'd have two, and then you would pop one, and then it would display another one, and you'd pop one, and you'd always have two. That's why it needs to be here, in between the process and the decision. So scrolling down, task 2. Michael is writing a program for a dice game, played with 3 dice. The player rolls a dice and is given points according to the following algorithm. So let's have a look. Okay. So it says there, state the value of the scores if the dice are rolled. So we've got 0, 9, and 0 are the answers. Okay. So let's go through 1. That 2, 4, 6. So we've got 2, 4, 6, and why is it 0? So it says there, we start and we roll the dice, and we ask the question: is dice 1, 2, and 3 equal? Well, they're not equal, so we have to follow the algorithm down. Okay. Are 2 of the dice equal? Well, no, neither of the dice are equal. So the automatic score is 0. We would end the game. Okay, and that's how that would work. 5 or 1, or 5, 5, 1, where you've got are 3 of the dice equal? Well, no, they're not equal. Are 2 of them equal? Yes, they are. So what we would do, we would calculate the score, which is a sum on the 2 dice, or the 2 equal dice, which gives us 10. And then what we would do is take that result and minus the sum on the 3rd dice, which will give us 9. Okay, 10 minus 1 gives us 9. 1, 3, 5, same process here. If we had 3 dice that were exactly the same, would they be equal? Yes. Well, it's dice 1 plus dice 2 plus dice 3, and that will give us a score and end the game. So some rolls of the dice produce a negative score. Okay, so it says here, state a set of 3 numbers that can be used to test whether the algorithm produces a negative score when it should, and state the expected output of your test data. Well, the answer's there. 115, or any answer where the sum of the 2 dice is less than the 3rd, the expected output will be a negative number. So, task 3. Task 3? Yeah, task 3. Task 3, which is a task which I've given you here. So have a go at task 3. So task 3, the results are here. So James is writing a program to simulate a dice game, the function random, which we looked at in lesson 4, the random module in Python. We're using the random.randint to generate a random number between 1 and 6. Okay, it generates a number between 1 and 6. And he has drawn a flowchart to represent the algorithm to calculate a player score when it is their turn. So Paul and Colleen play the game. We've got here, describe the rules of the game. Well, okay, so each player can throw the dice as many times as they like, but as soon as they throw a double, their score reverts to a 0 and their turn ends. Okay, so players take it in turns to throw the dice until one reaches a given target, but this is not shown on the flowchart. Okay. So let's interpret the flowchart. So we've got here, we've got dice 1, we've got a random number between 1 and 6. We've got dice 2, which is thrown, and you get a random number between 1 and 6. And we've got decision, does dice 1 equal dice 2? And if it does, it reverts to the score 0. It ends the game. If it doesn't, the score would equal dice 1 plus dice 2, and then you would have the option of having another go. So it says there, Paul rolls the dice 3 times, getting 6 and 2 on the first throw, and then 1 and 4 on the second throw, and then 2 and 3 on the third throw. Colleen also rolls the dice 3 times, getting 5 and 6 on the first throw, and then 4 and 6 on the second throw, and then 2 and 2 on the third throw. Okay, so what are the scores of each player? Well, Paul scores 8 plus 5 plus 5, so he scores 18. Colleen scores 0 because she threw a double on her third row. She would have done better if she stopped, okay, after the 2 throws. So if she stopped after the 2 throws, she would have done much better. Yeah, so that's that. So going on to the plenary. Okay, so this is what we did in the lesson. So as well as using sequence, selection, and iteration in algorithms, in task 3 we also use the inbuilt function, which we find out a bit more about in lesson 4, and we have. So we looked at the random module and the way the random module is built, and within there are certain functions within the random module, and in this case, in task 3, we use the random number generator to give us a random number of 1 to 6. Okay, so you can use many different inbuilt functions within programming to perform useful tasks without having to worry how the function actually works. More on that in lesson 4. Thanks for listening, and this is lesson 3 on problem solving.